Okay, so we are talking about sequences, which is a function whose domain is a set of positive integers. And that just means that our domain, our input values, are whole numbers, like 1, 2, 3, 4, 5, 6. All right, a finite sequence stops. So if it is called a finite sequence, that means there is an end. And an infinite sequence keeps going. There are two types of sequences. There is explicit sequence, and an explicit sequence tells you the relationship between your term, which we call a sub n, that's like the number we're finding, and the position. A sequence is a relationship between a position in a line, those positions are 1, 2, 3, 4, 5, 6, 7, 8, and a number, and that number is in that position. Explicit formulas tell you the relationship between the position and the term. You don't need to know the other terms in the sequence to tell me the term at place 5 or the term at place 7. We don't have to look back at the other terms to figure out what the term we want is. All right, so if I said, here is an explicit formula, find me a sub 10, that's the 10th term. You could find me a sub 10, which is the 10th term, by just plugging it into the formula. 3 times 10 minus 1. And that's 29. You don't have to know anything before, and you don't have to know anything after. The same thing here. This is an explicit formula, and I can say, find me the third term, which would be a sub 3. That n is the term number. So a sub 3, and that is 4 to the third power. I don't need to know what happened before, and I don't need to know what is happening afterwards to find that term. 4 to the third power is 64. Recursive formulas require you to have the terms before the term you're looking for. And so with a recursive formula, they often give you the first, or sometimes the first and second terms, because sometimes your formulas use multiple terms. So recursive formulas have us look back at the term before to figure out the following terms in the sequence. So it says a recursive formula for a sequence lists one or more initial terms and then defines the nth term using the terms before the nth term. So we have to look back. So these are examples of recursive formulas. They give us a sub 1, which is our first term. And that's 3. And then they give us the formula a sub n, so that whatever term we're looking for is equal to 2 times a sub n minus 1. And so that says that a sub n minus 1 is the term before. It's the term before. So if I was looking for, with this sequence, if I was looking for the third term, a sub 3, that is equal to 2 a sub 3 minus 1. That goes right there, which is 2 a sub 2. And so in order to find the third term, I have to have the second term. We don't have the second term. That's why they had to give us the beginning. In order to find the second term, that's 2 times a sub 2 minus 1, and that's 2 times a sub 1. Well, here, I've got the first term. The first term is 3. So this is 2 times 3, and that's 6. So now I know the second term is 6, and if I know the second term is 6, I can find the third term, which is 2 times 6, which is 12. And so that's a recursive formula where they have to give us the beginning term, or 2 terms, or sometimes 3 terms, in order for us to find the other terms in the sequence. You would not go in and say, oh, I want to find the 5th term. With recursive formulas, you always go in order. So we find the second term, then the third term, then the 4th term. But this is a good example showing you that if we have a recursive formula, you can't just dive in and say, okay, I'm going to find the fifth term. You have to find all of the terms leading up to that one. So you just make a list of them. All right. It says note that a sub n minus 1 is the term immediately before a sub n. That notation just means the term right before. All right, guys, let's look at some examples. The first couple examples want us to find the first 4 terms of an infinite sequence defined explicitly by each rule. They're just saying, hey, I gave you a formula. Find me the first 4 numbers, okay? So this is a function. We know how to make that table, right? So we make a table. There's x, and for us, it's f of x, because those are the variables I was given. And so if I'm looking for the first 4 terms, guys, we always start with 1. So our first 4 terms, our x values are going to be 1, 2, 3, and 4. And then what you do is you plug these numbers in right there for x. So this is 3 times 1 plus 2, which is 5. 3 times 2 plus 2 is 8. 3 times 3 plus 2 is 11. And 3 times 4 plus 2 is 14. And so these are the first 4 terms. This is our answer right here, the terms over here. This is our answer. All right. This is our place in line, or position. All right, that's our position. Our answer is these numbers right here. And so the way you would write that answer is you'd write it as a list of numbers. So we'd say 5, 8, 11, 14. Because that's what they asked us for, is the first 4 terms. Number 2 uses the sequence notation. And so here we have a sub n is equal to 3 to the n minus 1. Again, a sub n is just your actual term, and n is your position in line. And so when we make our table for this, our table is n and then a sub n, because it's like an input. N is your input and a sub n is your output. Again, n is your position in line, and so that always starts with 1. It's just 1, 2, 3, 4. All right. And then to find our actual term, we take this number and we plug it into this formula. So this is 3 to the 1 minus 1 power, which is 3 to the 0 power. And that is 1. The second term is 3 to the 2 minus 1, which is 3 to the first power, and that's 3. The third is 3 to the 3 minus 1, which is 3 squared, and that's 9. And the fourth is 3 to the 4 minus 1, which is 3 cubed, and that's 27. And again, these are just our position over here. Our actual answer is these numbers here, and we write that answer as a list of numbers separated with commas. So 1, 3, 9, 27. That's our answer. You do need to make sure you're showing your work, though. Don't just write down that list of numbers. We're going to show where it comes from. All right, the next couple of examples want us to find the explicit formula for each sequence. And again, explicit just means that your formula does not involve any of the previous terms. So when we look at 3 and 4, what we're doing is we're looking for a relationship between position and the term. And I find it is extremely helpful to actually put your terms in a table and then look for the relationship. So here, again, our table is n and a sub n, and what I'm going to do is I'm going to take these numbers and put them in the table. So my first position is 1, my second position is 4, my third position is 9, my fourth position is 16, and my fifth position is 25. And then we're looking for a relationship between the position and the term. And when you've put them in the table, sometimes it's easier to see that relationship. So in this case, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. You guys should see that relationship right there. The relationship I'm seeing is that A sub n is this term n squared, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And so our relationship is A sub n equals n squared. My actual term is equal to my position squared. It is exactly like looking for a formula given x and y values, guys, except that instead of using an x and a y, we're using an n and an a sub n. And again, a sub n is just your term at that position. Okay, so 4, we're going to do the same thing. We're going to make a table, so position and actual term. So at position 1, my actual term is 1. At position 2, my actual term is 1/2. At position 3, my actual term is 1/4. At position 4, my term is 1/8. And at position 5, my term is 1/16. And this is a little more complicated, but we can still see sort of a relationship. So I'm looking at these numbers over here, and I notice that 1/2, 1/4, 1/8, 1/16, those are all powers of 1/2. 1/2 to the first power, 1/2 squared, 1/2 to the third, 1/2 to the fourth. And in fact, 1 is 1/2 to the 0 power. And if I notice that, then I can look back, and again, I'm looking for a relationship between my position and the actual term. A sub n equals, well, if these are all powers of 1/2, A sub n is 1/2 to something. But it's not just to n, because this is 1/2 to the 0 power, and here my position is 1. So how do I get from a position of 1 to a power of 0? How do I get from a position of 2 to a power of 1? How do I get from a position of 3 to a power of 2? And if you start looking at the relationship there, 1 to 0, 2 to 1, 3 to 2, 4 to 3, 5 to 4, we can predict the next term, which would be 6 and 1/2 to a power of 5. The relationship here between the term and the actual, the position in line and the actual term is that it is 1/2 to the n minus 1. My position is 1, but my exponent is 0. 1 minus 1 is 0. My position is 2, but my exponent is 1. 2 minus 1 is 1. My position is 3, but my exponent is 2. 3 minus 1 is 2. All right, guys. Turn the page over. Looking at number 5. They want us to find the next 4 items of the sequence given by each recursive formula. So the front was all explicit formulas where you don't need the previous terms to find the next terms in line. Here they've given us a recursive formula, and they want us to find the next 4 terms. So I always start this by writing, we're going to make a list, but I include the term they gave me. So we have n and a sub n. And so when n is 1, a sub 1 is 6. They gave us that term. And then they want us to find the next 4 terms. So that's term 2, 3, 4, and 5, because they want us to find the next 4. And our formula here is that a sub n, so my whatever term I'm looking for, is equal to a sub n minus 1 plus 4. The previous term plus 4. So a sub 2 is equal to a sub 2 minus 1 plus 4, which is a sub 1 plus 4. That is 6 plus 4, which is 10. And so, it's a whole bunch of fancy notation just to say grab that previous term and add 4 to it. And so this is a sub 2. This is my second position in line. My third position is a sub 3 minus 1 plus 4, and that's a sub 2 plus 4. So we grab a sub 2, which is 10, and we add 4, that's 14. And again, that's a whole bunch of fancy notation to say grab that previous term and add 4 to it. A sub 4 is a sub 4 minus 1 plus 4, which is a sub 3 plus 4, which is 14 plus 4, and that's 18. And again, that 14 is just our previous term. We grab our previous term and we add 4. A sub 5 minus 1 plus 4 is a sub 5 plus 4, which is 18 plus 4, and that's 22. Again, we've grabbed the 18 from here, and we got 22. Now, again, like the other problems, like the explicit problems we did on the other side, our answer is these numbers right here. Those are our solutions. And the way you would write this answer is you'd list all of your terms in order, including the term they gave you, okay? So my sequence here is 6, that's what they gave me, comma 10, comma 14, comma 18, comma 22. That's my solution to this problem. All right, number 6 is again a recursive formula, which means that in order for us to find the following terms, we have to have the original term. And so again, we're going to make a table of values, n and a sub n. We're going to let that go. So n here is 1, 2, 3, 4, and 5. And they gave us our position of 1. It was 4. So a sub 2 is a sub 2 minus 1 plus n, which is our positions right there, so plus 2. So that's a sub 1 plus 2. That's 4 plus 2, which is 6. And in this case, we didn't just use the previous term, we also used our position. But that's not as important. All right, so a sub 3 is a sub 3 minus 1 plus 2, which is a sub 2 plus 2. And that is 6. I'm sorry, thank you so much, guys. It's a plus 3. Because we are using our position right here. This is our n value. Way to call me on that right away, guys. Well done. Okay, so that's 9. A sub 4 is a sub 4 minus 1 plus 4 because we're using our position. And that's a sub 3 plus 4, so that's 9 plus 4, which is 13. And again, all of this is a lot of fancy symbols to say that we're using the term right before to find the next term. We've got to use that number and plug it in to find the next term. A sub 5 minus 1 plus 5 is our 5th term. So that's a sub 4 plus 5, which is 13 plus 5, and that is 18. And again, that 13 comes from right there. And our solution is this list of numbers here. And we write them in order with commas. So 4, comma 6, comma 9, comma 13, comma 18. Like that. That is our answer.